hiring data engineers. And it's just you know, a coincidence that you are all data engineers. So if you feel free to come and join us. Okay, so hi everyone, welcome to CHEQ, to our exciting first meetup for ClickHouse here in Tel Aviv. I want to tell you a bit about CHEQ and what we do here, and then we'll talk about our journey to ClickHouse on Kubernetes. Fascinating journey, some would say. Thank you, Sharon, for presenting us with CHEQ's introduction, so I can focus on the technical stuff. So CHEQ is the global leader in go-to-market security. Go-to-market security is the motion of securing all your marketing, sales, and data operations from fake bots, fake users, all of the malicious things that you see out there. Basically, exploitation, fake traffic. You also seen and heard about it pretty much in the past few weeks and months. Taylor Swift ticketing system. Since I'm a boomer, I didn't know about this issue, but I was notified. And Elon Musk and fake bots on Twitter. It's a problem. It's a huge problem, and we're there to protect it. So, what is CHEQ's solution? Our CHEQ solution is based on a few pillars. So we have this proprietary fraud prevention algorithm. We use it on real time. We use like various algorithms in the back end and the front end to analyze data from various sources, including web traffic, customer behavior, and transactional data, things that a human cannot detect, a human eye cannot detect. We detect it and we can stop it in real time. I always give this example. Let's say, first of all, since we are implemented on each and every customer's tags, websites, landing pages, we handle massive amounts of data. I'll show you some numbers later in this presentation. So all landing pages, all sites come to our backend. We check it for validity, if it's a bot, if it's a fake user, whatever, and we can take actionable actions upon it. Block them, report them, whatever our customer want. So we use it using a proprietary fraud detection engine. It's applied in real time. We have many techniques, over 2,000 tests to check if a request is valid or not. Standing DNS, server-side signals. We're digging into the HTTP protocols, the JavaScript techniques, challenges. We have 2,000 challenges. About 2,000 challenges with users' browser data and dynamic JavaScript tests. Okay, so what does it mean to be, let's take an example. So some shoes company pays a lot of money for when a user Googles the best running shoes in the world, the best running shoes in the world, to be given an ad for, let's say, that shoes company. So basically, competitors, malicious bots, fraud, every fraud that you can think of is draining this PPC, pay-per-click campaigns. We're there to identify it and to prevent it. Okay, so enough said about CHEQ. Let's continue to our tech stack. Here. Okay, so we have hundreds of servers in production. We use dozens of microservices in production. Our main backend language is Node.js. We use it. Very scalable, very fast. We use it in production. Our more recent microservices are written in Golang, more the ones that need better throughput, better I/O, better CPU. We use React on the front end with TypeScript, both Node.js and both for JavaScript and Node.js. And we use Python for our ETL process and for a lot of data manipulation. The favorite language for data engineers. So some of the background on our data. So we are using ClickHouse, of course, for our main raw events, raw data storage. We use lots of Redis clusters, Amazon S3, Kinesis for event sourcing, PostgreSQL, MySQL, all the name dropping that you can think of, and of course Apache Airflow for our ETL processes. Okay, so that was kind of the setup for what we do here in CHEQ and some technical background. And let's deep dive into what we had before ClickHouse. So let's take 2.5 years ago. Well, all our events coming in from the web, we are saving it in raw. The raw events are saved in S3 for backup, for manipulation, for all other ETL processes. We used Athena and Presto for analytical queries and reports. So you can imagine it, if you don't know Athena, Athena is like an SQL abstraction over S3. It's a good service. I won't say it's not. It's very expensive, and for analytical queries, it can take a long, long time. Analytics were very, very slow. We're talking about 200 gigabytes per day in raw JSON files and about 600 gigabytes in Parquet files. We have about 35, actually it's not very updated, but between 35 to 40,000 requests per second. So we have a lot of traffic and we needed to manipulate it. And one of the main issues that we had with Athena and with this setup with S3 is that dashboarding is becoming a problem. You cannot have analytical queries, analytical reports in real time when your query runs for a few minutes. So we had to cache the results in S3 or whatever, Redis or per customer, and then serve it. So the cache was already, its lifetime for it wasn't for an hour, so the dashboard wasn't real time. We had a lot of problems back then. Okay, so then we started POCing with ClickHouse. And we started to see the promised land with ClickHouse and the swiftness of its queries, the ingestion that it gave us. We started POCing with ClickHouse on a physical machine. And now we thought, well, this looks great. Let's progress into ClickHouse on production. But then we had to choose between running ClickHouse on a physical cluster or on a managed cloud, or running it on Kubernetes. So we took on the bold decision of running it on Kubernetes. Some of the things that you may all know Kubernetes is good at, but I'll just give a taste. So scalability, this is far more easy scaling your ClickHouse nodes with Kubernetes, right? You have the horizontal pod autoscaler. You can add, you can vertically scale or horizontally scale your nodes. You have high availability, right? Automatic failover and self-healing, the readiness probes, the healthiness probe, everything that is already built into Kubernetes, you can enjoy with ClickHouse on Kubernetes. So resource allocation, ClickHouse consumes, in some cases, a lot of CPU, memory, networking, everything that you can think of. You need to have fine-grained control. You can have it with Kubernetes. And of course, automation, everything that is the deployment, the scaling of your ClickHouse clusters. You spend a lot less time in managing your cluster and a lot more time in the actual data needs. Okay, so a few more notes that we have that were actually very important for us as CHEQ, not very generic in Kubernetes, was that the disks are isolated from machines and can be easily reattached. So if you drop a disk, you can reattach it to the pods. We already had our cloud-native tools in place, right? We have the Prometheus, we have the Grafana, we have everything that we need already in place. Wanted to take advantage of these tools and not reinventing the wheel every time and deploying it again. Inter-service networking. ClickHouse is great. Now we need our services to consume this data and show it to customers, reports, whatever. We wanted them to talk directly to ClickHouse. So in Vision, we envisioned that all of our Kubernetes advantages plus all of our ClickHouse advantages in one place, and it looked like the promised land, and we went ahead with it. So we did have problems at first. This was take one. This was about 2 years ago. So we ran with the open source ClickHouse operator. It's good. It's open source. It has a lot of support out there. We had 10 minutes per pod until readiness because we had to run chmod for all of the files and the pod. So every update, every bug fix, every change in configuration took us a long time. That was because we were not very bright enough to have to take the next step before, but we had a long YAML with thousands of rows with everything in place, in line, with one YAML file. So reverting made impossible. So we had a lot of, well, we need to redeploy it again, a lot of late nights. So then we became a bit smarter. We converted the YAML file to proprietary Helm chart. Our great DevOps is somewhere. Where are you? Okay.
Residing.
Yeah, okay. So we reduced the readiness time to, we took everything in the YAML file first and we broke it down to Helm charts. And some of you, probably most of you know what a Helm chart. Helm is actually the application management for Kubernetes. So we took on this long YAML, broken it down for configurations, updates, everything made far more easier. By the way, we can open source our Helm chart for everyone if you want to. So readiness time reduced to 2 minutes per pod by using pod security context, all the things that we didn't have the mindset to do before. Rollout made a lot better. Stability increased. We had happy ClickHouse consumers, both internally, by the way. We are a company very reliant on data. We have cyber researchers, we have support, customer success, whatever you can think of is manipulating our data. So we had super fast queries. I always give the example of a query took about 50 minutes in Athena, running 3 seconds on ClickHouse. Okay, that was a magnitude of magnitudes in order of performance. So we have, and currently we're running Kubernetes on ClickHouse and Kubernetes for about 1.5 years on production. Full. We didn't have a lot of failures. I know one will happen today because I spoke about it, but well, I'm not on call, right? Okay, so super fast queries. Well, we're very happy, and it sounds like a great decision, and it sounds like a great happy path. But okay, so takeaways. ClickHouse on Kubernetes, we're very satisfied with it. It can provide many benefits. It can, but you need to know that it also embeds some difficulties. Okay, so the complexity of setting up and maintaining a ClickHouse cluster, for those of you, especially for the organizations that are not very familiar with Kubernetes, the complexity is not very. It's not too complex, but it is complex. And again, we'll open source our Helm chart to help everyone wanting to run ClickHouse on Kubernetes, not the competitors, but just you guys. Okay. So, organization not familiar with Kubernetes containerization, you need to have this expertise in the organization. Resource requirements. Take in mind that if you thought that you're running like a small cluster with a small amount of nodes, ClickHouse can take and it should take a lot of resources, CPU, memory, storage. So pay good attention to the costs. The costs there. Some of the things we had is when you drop an installation and reinstall it, the disks are detached, but you forget to clean it up, and then you see that you have an 8 terabyte disk that is provisioned for a few days, and you will pay for that a lot of money. Networking, so inter-service networking, the ClickHouse needs to have a good networking between the nodes and with the zookeepers to the nodes. So make sure you configure the networking very good, and data durability. Make sure that you have fallbacks, like when a pod crashes, a node crashes, you didn't have the time to consume all of your events, ingest them. Make sure you have cold and hot storage policies. We have hot storage, cold storage, and Glacier for those events that came in a long time ago. We do not serve every click, even from a few months back. We serve it in storage. So ClickHouse and Kubernetes can help you with the storage policies. And I think that's about the time for questions. Okay. No questions? It means, yeah.
How did you understand that you want to try ClickHouse?
Well, ClickHouse or on Kubernetes?
No, ClickHouse.
Okay, so that's a good question. So our bright CTO, which is not here.
Not here.
Okay. Okay. So our bright CTO took this. Actually, I first joined about around the time that he started POCing with ClickHouse, and then I thought, well, he probably knows what he's doing, and he knows what he's doing. But then we started to do like a checklist of every database that we thought that might be good out there. We started reading a lot, but basically a lot of recommendations from companies around our size, with friends in the industry that told us, well, we should go to ClickHouse. When we invested a lot of time POCing the cost, the complexity to manipulate, a lot of different pillars, disks, size, whatever we need for our specific use case. It might not be for every organization, but it is right for us. And as for the why Kubernetes, I'm a fan of Kubernetes, and basically back then I was calling the shots, right? I think, and then we started saying, well, why not combine the two? And we saw that it could be a good test case. Yeah.
Can you please explain the difference between the cold storage and Glacier? I will give you a point of reference. For example, in my project I worked on, or with the analytical database that I worked on, you have last day or last week is like a cold storage, and you have some kind of retention period, which is the cold storage. I never encountered the Glacier except S3, so can you explain what you mean by Glacier?
Yeah, so basically our S3 Glacier goes to the Glacier in S3. So basically we have ETL processes that take the obsolete data, the things that the user do not query oftenly, and we take them to like a different storage policies, Glacier and S3. But we're using heavily mostly the hot and cold storage. Cold storage on S3, we're using the built-in S3 support in ClickHouse, and the hot storage just disks, EDS disks. Yeah, sure.
So when you say about the cold storage, do you use the merge tree engine with the like TTL to move it to the S3, or do you move it?
I'm not sure about it. I think we need to ask. I mean, we can take it. We can have a follow-up question on that. I'm not really. It's in the specific details I cannot.
Yes.
Yeah, okay. It's a very concrete question. Yeah. Yes, sure. Go ahead.
Yes, when you mentioned ClickHouse operator, open source, do you mean Altivity ClickHouse operator?
Yes.
Okay, and also the next question, when you scale your ClickHouse cluster by adding new shards, do you perform some rebalance? How do you perform?
So we have a lot. The first few. Well, you cannot really run a cluster on like spots, right, or something like that. So yes, we do rebalance, but we haven't had the joy of rebalancing in a very long period of time because we use dedicated servers, like 3 huge monsters in each environment. By the way, we are GDPR compliant, so we use different clusters for ClickHouse on every region. But so it's costly. But basically, yeah, when we had to do it, we had to rebalance, but it didn't occur for a very long time. Yeah.
You said you had some problems with Zookeeper.
So
You said you had some problems with Zookeeper.
Yeah.
And you also said you constructed your own intelligence. I wonder if you maybe used ClickHouse Keeper in your website. And I'm asking that because we also had some problems with the coordination between Zookeeper and ClickHouse. It caused some data loss.
Well, basically, I didn't say that we had problems with Zookeeper. Just the regular problems with Zookeeper, but not something specific. So this is the DevOps guy. Everything that went good, I'll take the credit. Everything that is worse, that is not good, to blame him. Yeah, some more questions. Yeah.
So everyone knows who uses ClickHouse. ClickHouse need to be ingested with a huge batch size. So what do you use for batching? How you ingest it?
Yeah, so we use Amazon Kinesis. It works good. It's it's recorded, but It's far less expensive than some of the services that use Kafka today. I don't want to mention any companies out there. No, okay? Even proprietary AWS. So we use Amazon Kinesis. We have our own consumers that we built in-house, and they are using batch sizes, which are configurable, and basically just trial and error that we had. Mostly error until we had we had to ingest, you know, batch sizes of a few thousand, then a few hundreds, and then a few singular. But I think the current number I need to dig it up.
50,000 or 5 minutes.
There you go. 50,000 or 5 minutes. Some more questions? No? Yeah, sure.
Have you tried using spots for scaling?
No.
No?
No. Let's say we had a lot of, not a lot, but we had issues at first to understand the mechanism that it uses to rebalance and with the zookeepers. So we say, well, let's go with the on-demand for now, and we basically stuck with that. Spots are very good. We do it with ETL processes that are offline, that do not require real time. But no, spots on production is, I mean, yeah, you know what I mean. Yes.
Can you describe your cluster, shards, replicas?
Yeah, so our cluster is pretty simple. It has 3 monster machines, no sharding, 3 replicas. I can't give you the exact number of CPUs, RAM, but it's a huge, huge machine. Everything deployed on Kubernetes, and again, we have dedicated service for zookeepers. Again, 3, and we have for the hot storage, we have the EBS IO, like the best IOPS out there.
It's free per region.
3 per region, yeah, per region. I'm talking about 1 cluster per region, so production EU, production several regions in US, and of course dev and state.
Replicas per region?
Sorry? 3 replicas per region, yes.
Can I ask why you need 3 replicas?
Why do you need 3 replicas? Because we save personnel, PII in our ClickHouse, so the compliance obligates us to have, oh, you're saying why 3 replicas? We need to have like high availability for each region because we have customers in the EU and the US, but we save PII in that database, so we need to have compliance with GDPR states that every raw data, PII, would need to be saved in the EU and not taken outside of the US. By the way, aggregated data is fine, and we save it in only 1 cluster. We also mask some of the data, of course, to keep our security much more at a high level.
Let's leave it at that.
Sorry?
Let's leave it at that.
Yeah, thank you very much.